right. So, let's see if this works. Guys, say hi in the chat if you're here. Quickly want to see the quality because it stutters here a bit in the preview. Looks fine. Looks fine. All right. Hope everybody has a good time. I hope you have an awesome day. For most people, it's starting in the US. For us in Europe, we're already here. 4 p.m. Hey, Philip. Hello. Hi. Welcome. Let me see. Everything all right on LinkedIn? Hello, LinkedIn user. Hi. Yeah. Good morning to you. I still feel like it's sad that LinkedIn doesn't show anymore that somebody is live. It's like as if they don't want it anymore. Hey Olivia, of course this will be recorded. This will go into just the YouTube channel and will then be available in the YouTube channel. Olivia. Yeah, today I have a interesting topic and let me know your thoughts on this. If you're a data scientist, put a 1 in the chat if you're a data scientist, and then let's go through this. I prepared today, I prepared for us a roadmap from data scientist to a data engineer, or also for data scientists who want to learn data engineering, right? This is something that is super important. A lot of data scientists are in the position where they build their machine learning, they build their analytics, but actually they also need to do some engineering, and they want to do good engineering job and not just like stitch stuff together and have no idea how to stitch stuff together, right? Build a minimum viable product. This is one of the things that a lot of scientists need to do. Also, we're I think last time on the podcast or on the live stream, we were looking into Google Trends, and we were looking into which jobs are going up, which jobs are going down, and we were seeing that data scientist actually is going down. So the demand for data scientists is lower, and engineering and analysts is going up. So I think this is, you most likely see this on your end as well, that it's harder to get a job as a data scientist. It used to be super sexy and everybody wanted to become a data scientist, but nowadays people have figured out, okay, we have a problem. Just the science brings us not far enough. We need somebody who also can do the engineering part, right? So, and that's what we're here for. I have a few ideas how to do this. I created a roadmap for you. I'm doing this with a bunch of coaching students actually, but if you're interested in this, you can also go to the academy and look at these parts in the academy. It's everything's there if you want to do stuff like this self-paced, or if you just want to get an idea here. So let me bring out the roadmap. And yeah, it's hard to get it's hard to get any tech job right now. It's more difficult, but I mean, 2 of my students in the coaching after 4 months have found a job this month. So, and they said this January it was a lot simpler to get a job. There were more openings, and they got invited to more do more interviews. This might be because we optimized their CV and they had some portfolio projects to actually showcase. But I think generally also when you look at now, when you go on LinkedIn and do a quicker search and search for data engineer or data scientist in your, let me go there. Here, actually, I can show you. Basically, when you're looking for a job, what I would do is I would go into connections. And what I would do is I would here search with filters. And then you go, for instance, second. And you go actively hiring, for instance, data engineer. Or let's say, you could also search for senior data engineer. Let's just do this, show results. And then if you have a bit of a larger network, you see here I have 20 tabs here for people that are searching data engineers, right? Here, Parvinder in London, click on it. And then you're going to see here, come on, load. Here, hiring data engineer. Okay, this is actually for Prime Video, but so you see, data engineer job, description. Let me see how many people applied to this. Most likely a lot. Okay, 500 people. Yeah, but like, that's how it is. But I think you know what I mean, right? You can right now go on LinkedIn. You can find all of this, and you can find jobs. You can apply to jobs, and there are a lot out there right now. It was. At some point, it was really terrible, but nowadays it's getting a lot better. I feel like. I'm going to sell a course. I mean, I'm not selling individual courses, but I'm going to show you. I'm doing this with my academy, right? I have multiple people in the academy, or not multiple people, multiple types of people like analysts, scientists, software developers, database administrators, and so on and so on and so on. And they all want to get into data engineering for various reasons, making the switch or adding to it. And for them, I set up roadmaps. We're going to bring out the roadmaps this or next month, basically in February, to the website and everywhere, so it's easier to work through it because you don't need I'm sure you know I have my data engineering academy at learndataengineer.com where you can basically join the academy with over 30 courses and so on, but you don't have to work through everything. And that's what I'm going to show you here. So without further ado, let's jump into this. So the idea here is, where's my roadmap? Here's my roadmap. So the idea was, okay, I was thinking, like, what is it that a data scientist need to do, right? Or maybe let's quickly jump into the goals. So what are a few goals that a data scientist, or that makes sense for a data scientist to work on? I set the goal number one, like build an end-to-end data pipeline or machine learning data pipeline, right? As a scientist, you know machine learning, but you need to bring this into production. And it doesn't need to be super difficult, like an ETL pipeline. Just bring this into production with AWS or Azure or GCP. It doesn't really matter. I have here AWS just as an example. Again, this all is an example, right? And then as the second part, I would say bring in CI/CD and especially use something with containerization, so that it's easy for you to deploy your algorithm. It's easy for you to replace the algorithm. And in a Docker environment, it is a lot simpler. And you can do this on AWS very easily. Then I would look into the lakehouse concept on AWS. Again, I'm going to show you everything that that includes this. These are the rough goals, right? Lakehouse concept on AWS, that is important because as a scientist, you need to do data exploration at various steps in the process, in the beginning or in the middle, somewhere where new data is coming in, or you want to like look at something. And I think the whole lakehouse concept is super important in this. And we have something, and this is AWS based, this one here, right? So again, the same thing you can do for Azure. So this is something I highly recommend. Look into the lakehouse, storing data in the data lake, and then using tools to actually then query and analyze the data directly from the data lake. Although also here on the at the end, I would say build a data warehouse, because somewhere your data needs to go. Build a data warehouse, orchestrate your pipelines with AWS, right? With AWS, not with Airflow. I think that is super important to have this or keep this in mind, that you most likely need to schedule, or you need to plan your whole pipelines. If you have multiple steps of processing within your ML pipeline, you need to have some way of orchestrate this. There are tools out there that are used by the cloud platforms themselves, but also this is something that you need to look at from an external tool. And Airflow is one of these that you can do, or Daxter or something. But here my example is with Airflow. Let me check something. Okay, my audio wasn't high enough. Okay. But you can understand me, right? Is everything good, right? Sound is good. It was a bit lower a second ago. It should be a bit higher now, right? Because somehow this changes automatically. I don't know why. And if I don't check it all the time, it changes. Well, I guess everything is right. Right, and then I would say like something that you need to able, and I added this here as a new thing, analyze your training logs, or analyze your data that you're using for the data science part with something like Elasticsearch, right? You're training your application of the models are going to create some metadata, and you want to look through this metadata, and that's where you need to have a good solution, because looking through log files, you don't want to do this. And Elasticsearch is actually a cool way of doing this. Somebody says hello from Belgium. Hello to Belgium, neighbor. Very close to us here. As Germans. So let's look at the pipeline, or at the roadmap. I would say, first of all, as scientists, what you need to do is you need to start looking into platform and pipeline design, because this is often very difficult. What areas are there that are important in a data platform, like how do you get the data in, processing, storage, visualization, right? And which tools are in each of these areas. I think that is super important. You need to do this. Then working with APIs. This is something you need to learn. This has two use cases. One, you need to either get your data from an API, or you need to write your data to an API, because like you have your system, and then to one side of you, there's the external system that gives you the data. To the other side, there's the external system where you're sending your data to. It's all possible, and that is one of the important things, like working with external APIs. The other thing, though, is also hosting your own APIs. Basically, wrapping your algorithm, your model around, or wrapping an API around your model to make it easily usable for other people, and modular, and also very often with the storage of the metadata and so on. So start working with APIs, and then start using Docker. If you haven't used Docker before, I think for a scientist, this is something that is very important. You might be used to this in a small scale, where you run a container somewhere on a local machine, or on training, or I don't know. But this is something, if you don't have this, you need to learn this. I don't know. Everybody who knows Docker here? Do you guys know Docker? Have you tried this out? Put it in the comments. I think it's one of the important tools nowadays that you need, and you're also going to use this in this roadmap then here later, when we go on to AWS and when we use this there. But nevertheless, before I would jump into this, I would actually I recommend people to learn relational data modeling and also like understand all the types of data pipelines that are there, right? Not data pipelines, data stores that are there, relational data stores, no SQL data stores like key value stores, document stores, and so on. Understand the data lake, understand the data warehouse. And then I think a relational data modeling and querying data from a SQL data store or with SQL from a relational database. I think this is very important because very often you need to work with metadata. Like let's say in an environment where you're working with a transactional database that has customer transactions in there, and you have other data that you're analyzing and you want to relate this to the customer data, you need to query the customer data most likely somehow on the fly. Or if you have a streaming pipeline that actually needs to access data or get additional data from somewhere else, I think working with the relational databases is important. And that's why I recommend this. And then I would say, like, do something like machine learning and containerization on AWS, that you know how to build a pipeline, or that you know how to like build the ETL pipeline, and you know how to deploy containers on the cloud. I see Jonas says here, yes, he's using Docker. Very nice, very nice. I hope this was easy for you. Like, Docker is a cool concept and it's not super hard to actually learn. And then with the whole machine learning, containerization, like building a pipeline, I would also look into CI/CD, basically how to bring your code into or manage your code with GitHub, and then have GitHub Actions actually build the Docker containers and then deploy them to the cloud. I think that is something that is super helpful. Yeah, and then again, working with the lakehouse and dimensional modeling, as I said, and Airflow. I think these are the important parts. No, that is not the case. People used to switch a lot from engineer to scientist, and nowadays I have a lot of people that either are data scientists and said, I'm fed up. I've been tricked into data science because it was cool and because I thought this is my thing, but I'm actually an engineer. Or I have people that come to me and say they want to learn data engineering because they are scientists and they actually need to build something because there is nobody else there. And that is right now, that is the case. Yeah. Let me quickly try something. I want to quickly look for something. Here, see? Remember when I did for data engineer, there were 20, here there were 20 tabs, and for scientists only 10, basically half of this. Half of the amount, or half the amount of jobs that are actually available in my second network here for data scientists compared to data engineer. See, this goes to 20, and the scientist only goes to 10. So that is something that people do a lot, right? Because the demand is down, and also they need it. But let's keep at this. So what am I talking about? What are the important parts? that you need. So for this, how do I do this with my coaching students? Of course, for them, it always differs because people have other basics, they have other goals. And so it's not necessarily these goals, but let's say you're a data scientist and you want to just learn data engineering and you go through, or you say, okay, Andreas, I see you have a lot of stuff in the academy. I'm guessing I don't need everything. Here's what you need to do. And let me show you. One sec. Of course, I'm locked out here. Okay. So what I recommend, how I would start is in my Data Engineering Academy, we have a course that's called Platform and Pipeline Design, right? And this is not a super big course. This basically gives you the fundamentals of, okay, what do you need, right? You need to understand my platform blueprint, how to get the data in, how to connect with external sources, store, processing, buffers, and how to visualize. A bit of, okay, what's a batch pipeline? What's a streaming pipeline? Lambda architecture, which is still important. These kind of things. I think this is very important for you to actually learn, right? This is the first step, I would say. Then from there, when we look at the platform here, at the roadmap, I would look into API design. Now, the thing is with APIs, and you can see all of this if you go, let me create an incognito window. You can see all of this when you go to all courses here. When you're not logged in, you can go to all courses and you're going to see all of them here. Everything that I just shown you, you can also explore here. And we're going to put links in the description here afterwards. If you rewatch this as a recording. So, because I think it's important, what do you do here? Understand hosting versus using APIs, like the methods of media types, response codes, basically the basics here, right? API parameters. And then if, in case you need it, I would go into API design and basically look into, okay, how do I use basically posting, getting data, updating data is also here somewhere. And then how can I deploy something as simply as a container on the cloud? I think that is very important. And with that, and the cool thing is with Fast API, and you can easily try this, you can easily build this, and it's very visual, and it's easy to design and easy to learn, and then to test, for instance, with something like a Postman. I think that is very important. I would do this. And afterwards, I would say, okay, I would, and you already seen Docker here, I would look into Docker, into the Docker fundamentals, understand the concepts, like what's the difference between Docker and virtual machines. The terminology is always important, how to install it, and then like a small CLI cheat sheet and how to use Docker in production. And basically build a program standalone and then with dependencies. I think that is something that you need to do. Right? I don't have that much of images here, but I think you get the point. Basically, do I have here? Didn't I have here a? Let me see. Wasn't I showing here a chart? Come on. Hello world. I think that's the same thing. Portainer I also showed here. How to manage containers. Yeah. So that is one of the things. And with that, when we look at the roadmap, we're already here, right? We already have a lot of the basics. You can already do a lot with this. Now then I would go into relational data modeling, and for that, I recommend doing two things. What I would do is I would go and I would do a very simple course. As I said, I have this here where you're looking through different data stores, right? Relational databases, wide column stores, document stores, key value stores, data warehouse. Also, we have our workshop here that we recently did in November, end of November, where you're going to basically understand the fundamentals. We have a data set. How does this data look in different data stores when you model it, right? I think that is something, this is a good start. And then depending on if you want this, I would go into relational data modeling. And then actually Eka did this here. And then learn a bit about MySQL, about data stores, and about the whole design process, using something like Workbench to actually design your database. These kind of things, right? Primary keys, foreign keys. I think that is very, very important. Right? Entities, attributes, right? ER, green ER diagram. These things are important, and then hosted. And with that, where are we? We're here, and now basically from there on out, we have the data dimensional data modeling. I would say this is optional, but from there on, this is all a lot hands-on. My example here is with the cloud. Oh, one thing I actually forgot. As a scientist, I also recommend look into something like SQL for data engineers. Very often as a scientist, you don't have that much experience with SQL or SQL, how people call this. So look into like select, grouping, joins, right? Common table expressions and the window functions. These kind of things are important. And you can easily train this. It's not super difficult. And I think these are basics that make sense. It doesn't take forever, as you can see. This is not super long. It doesn't take forever, but it can be very helpful as a scientist. And then I recommend going into AWS, right? Go into AWS and and create something like this where you're using an external API like Twitter, or in this case, actually I changed this out from Twitter. We adopted this, and it's strange. I thought I changed it on the website. Use an external API. We're using the Guardian and News API here. Extract the data and basically load it here, analyze the sentiment, and then store the data into S3 or in a relational database, right? And from there, then create a dashboard that you create on your PC with Streamlit, put this image to ECR and then a container registry, and then deploy this on Fargate as a container. And this method here, or this process, you can use for everything. You can also use this as, let's say you have a larger training or some kind of a model that you want to deploy. You can also deploy this. And if you as I said, package this model into an API, then you can actually host an API here in ECS that you then can query from outside with other tools, right? You could say, okay, my Lambda function here actually doesn't do the sentiment analysis in the function. It actually then calls my API that is hosted as a container, right? My model here, and gets the data back from the API that I host here. I think this is a really cool project to do, and very hands-on. Look into, because then you're going to work with security groups. You're going to work with RDS here. You're going to work with, what is that? That is with Lambda. In this, we also, the GitHub, project setup, and then basically you can create yourself a user interface. It's very simple, but it's with Streamlit, a quick user interface. It always makes sense to spin up a quick user interface as a scientist. Have the knowledge to do this, and and then use this and show it. Yeah, use Fargate and so on. So I think these are important things to actually learn. And virtual environment, stopping the task on ECS after you finish is also very important. We're right now. We have stuff on Azure. We're deploying we have one of the. Let me see. Can I show that? Where's my incognito window here? Here we have one new, where we released the first version, and it's going to come more next month on the 16th or on the 19th. Another thing with Azure, this is not necessarily with Docker, but it's basically where you have an external API, you use Data Factory to get the data in, Azure Data Lake as a storage, and then Synapse Analytics and Synapse Notebooks, Power BI. That is one of the things that we have, and all managed basically through Terraform. And the other thing that you can do is Azure. Here we have one where you are. Was that already the first picture here? Where you basically can create. I thought that we had a nicer image here. Where basically you can get data, you can stream it in, and use then Event Hub and go basically with analyzing the data up to Power BI, where you then visualize your data. I need to change out this image, right? So we're working here with Key Vault, with API management, with Event Hub, Cosmos DB, that kind of things. But I mean, the same thing that I was saying here for AWS, you can also do this on Azure. It's not a big deal. Once you understand this works almost the same way. The other thing that I also recommend is that you go a bit more into data warehouse and data lakes, right? And one of the things that I highly recommend is doing something like this. And for us, this is an example with AWS and with GCP, where you have your data laying around in your S3 bucket, and you query the data with Athena using the data catalog, and then visualizing the data, for instance, with QuickSight. We also this also has a part where you're using Redshift instead of Athena, or Redshift Spectrum here, to actually query the data. This has the setup on GCP, setup on AWS, and as I said here, this has a bonus configure Redshift Spectrum with S3, so you can, when you have Redshift data warehouse, you can actually use this whole process. And with that, I think, with that, we're already basically here. You're almost finished as a scientist. Now, either you go a bit more into the dimensional modeling part that I always also recommend. It's always useful for you to understand this. And there's also something that Eka created here for us. Basically understand the different use cases and go through an example, go through data modeling, and then use, in this case, we use DuckDB to actually then deploy our, basically build and then deploy the data warehouse. I think these are important things. It's debatable if this is important for the scientist. I think at least as an optional thing, this is really cool and makes sense. Airflow, I mean, Airflow is something you have to look into, right? Because your pipelines most likely are multi-stage pipelines, and you need to understand like how does Airflow work? How can you interact with pipelines? How do you create a simple ETL process here? And then you're going to say, okay, I'm connecting this, for instance, to AWS, right? What if one has not a data science academic IT background? Would it still be positive to become a data engineer? I think, well, it always depends on exactly what you're doing. Like if you have absolutely zero computer science background, it is going to be very difficult, right? Because one of the bases as for an engineer is you need to understand some coding, and I left out Python here. I left out that's why I put SQL for data engineers, or SQL. Yeah. That's why I actually have this more as an optional thing, because like, do you really need this, or do you really need to learn this again as a data scientist? And if you are, I'm getting confused here. So Python you need, SQL you need, and these are two very important things in the beginning, right? Working with relational databases, actually being able to code. And if you don't have that background, it's difficult. It's going to take you longer than somebody who's coming from a computer science background and who understands a bit how all these kind of things work. So, but if you have the time, of course, that absolutely makes sense to look into. Yeah, but again, Katayon, it always depends on your background, and maybe you already have a few fundamentals, but as a complete beginner, it's always difficult. It's not witchcraft, but it will take more effort to actually get there, right? Because you're missing the fundamentals. But let me show you one more thing. I think one more thing that is super helpful is actually doing something with a log analysis with Elasticsearch, like using Elasticsearch for your application logs as a scientist, so that you don't, instead of writing stuff into files or struggling with some kind of database, I recommend totally working with something like Elasticsearch, and I have something where it's basically where we compare this with normal databases. Oh, this image is broken here. Need to fix this. And then, because in Elasticsearch you can use your logs, put them directly in, right? These logs get indexed, the variables in there get indexed, the attributes, because this is based on JSON. And then you can build yourself UIs on top of Elasticsearch. You can, of course, you can just do a search in your files, in your logs. I think this is very helpful. The elk stack is awesome. You can also create, you can keep Kibana dashboards. Is that here? You could also connect this with something like Grafana or whatever you're running. I think it's super cool. And yeah. And then I think we're through with the roadmap, right? It's everything. That's what I mean. Now it seems big, but I would just start. And if you already get to that point here, that you understand Docker, you understand how to work with databases, with a relational database, you understand how APIs work, and you can build an API, and then you can like create an ETL pipeline. It doesn't matter if it's on AWS, if it's on Azure or GCP. If you already know this, then super good. That's everything you need to know. You don't need to know more. you're already making huge progress, because then you understand how to design the pipeline, you understand how to build the pipeline, and you're self-reliant, right? Here's a question. I'm just joining. Perhaps you already answered this, but what are the certifications you think are recommendable once you learn all this? As a data scientist wanting to learn more of the data engineering world, go with one of the data engineering certifications of one of the clouds. I would just, basically, it doesn't really matter which cloud. I think if you're, one second, something is tangled up here. If you're going with something like AWS, it's like idiot proof. I mean, AWS is something you can use all the time. It's the most used cloud vendor. So I would just look into like building up to the certifications there. One sec. Give me one sec. Because in the cookbook, in my cookbook that you can use on GitHub, like just search data engineering cookbook and then you're going to find this. I have one section here with recommended books, courses, podcasts, and here actually are certifications. And these are the certifications that make sense here. And you can find the links. So basically, as a beginner AWS Cloud Certificate Practitioner, that is something that maybe makes sense to just start, right? Get familiar with the AWS platform, and then do something like either AWS Certified Solution Architect, AWS Certified Data Engineer, which are intermediate courses, or then go into Certified Solution Architect. Right, but that is an expert course. I think these are good, and these are totally fine. A lot of people do the Microsoft DP 203 as a intermediate one, or they start with the Azure Data Fundamentals part. Yeah, I think also this year Azure Certified Azure Fundamentals is something for. Do they? Yeah, they also have a data engineer associate, but a lot of people use the DB 203 here. So I think I'm not against certifications, but I think a good portfolio with a few projects in there, that is very helpful. And I see this from my coaching students. In the beginning, I mentioned like 2 of them actually after 4 months now got a new job as a data engineer. One from a data analyst. He came from a data analyst side and made the switch to a data engineer. And the other was working for a few months as a junior engineer until the department was closed at his old company and was looking for a new job. And he got now as a data engineer, associate engineer job, because he learned a lot. And so it makes sense to do this portfolio, because what they said is in the interview process at some point, I don't know if it was in the first or more in the second interview, they were talking a lot about the portfolio projects, right? Because this helps the interviewer to actually, or the person interviewing you from the department who wants to work with you, is able to ask you concrete questions about your portfolio that you have on GitHub, about the projects that I've just shown, right? Because this you can package into multiple projects, and this way people can actually then ask you questions around this. It's going to be easy for you to answer questions around this, and also if you don't know something, you most likely can relate this to something that you have looked here. Yeah, of course. I would also look into what job descriptions are saying. Of course, you need to look into what job descriptions are saying. That is, like, do a bit of research. I always recommend doing a bit of research. For instance, here in the EU, Azure is very strong. Like, a lot of companies use Azure. My feeling is always because they already have contracts with Microsoft, and Microsoft, they're used to working, and then so they just go with Microsoft. In other countries, you most likely need AWS, right? Or in certain industries like startups, AWS is not that important. Maybe it's more GCP. That is something you need to actually figure out. You need to go out and you need to do a bit of research. And the easiest way, like I said, the easiest way is here. Go to LinkedIn, do a job search for either here, search for people in your connections. If you don't have that many, you can also add here the third connection row, right? Now I have 96 people that are searching for data engineers, right? So super, super large. Or just go into, where is that actually? Go into jobs here and start searching for data engineer. Right? And then look, you can usually, instead of, where is it? All filters. You can even search by location, right? This is just for Germany. And this way you can get a bit of an idea what's coming. DP700 with a good portfolio with a lot of projects are better. DP700, do I have this on the list here? Actually, don't have that on the list here. This needs to go on the list. No. Okay, I'm going to keep that in mind. Can I create a data engineering portfolio project without paying for AWS for a while? Of course, like AWS, they have a free tier, and you can use in the free tier a lot of stuff. So I think that is super, super important to do, and it's easy to do. So you can definitely do that. Start here on the cloud, do a bit of research of which tools are free. But yeah, you're the first few months you're not going to pay anything. Or even like if there are certain services that are not under the free tier, but when you work with small amounts of data, because for learning that your data pipeline doesn't need to be working with huge amounts of data. It's more about like building the pipeline and understanding, okay, what are the implications for scaling, but like that kind of things is not a big problem. I know we're coming back to as a beginner, know a little SQL and Python. That is a good start. That's a very good start. That's a very good start. Let me see if I can bring this up. I'm going to talk about this next time, but I can give you a bit of a short preview. One sec. Because didn't I have here? Basically what I was looking at, like if you're a graduate or a beginner, right? What do you need? You need to understand platform and pipeline design basics. You need to practice relational and dimensional data modeling, because that is something that is very important. You need to work on a transactional and on a analytical context. You need to be able to work with the data, store the data, query the data. You need to get experience working with Python and SQL as a data engineer with data, right? I would work with data, and then I would start building a first pipeline on the cloud. It doesn't really matter which cloud. Could be a streaming pipeline, could be a simple ETL pipeline. I think that is That is important. And from there, you have a lot of options. You could go into Spark, right? If you're building ETL pipeline, you could go into Spark streaming. You could also, right now, Snowflake as a platform and dbt as a tool for transforming data is super important. So these kind of things you could look into, and it's really not a big deal. I'm going to bring out or do another stream about possible roadmaps for graduates or for beginners. Andres, I'm a data engineer. Can you please share path and tips for becoming a data scientist? Absolutely not. I would, but I have no idea. I'm not a data scientist, so I can't give you this. I would maybe ask like Andrew Jones with Data Science Infinity. He has his own thing. He also teaches data science there. Maybe that can help you, but I'm in no way, shape, or form capable of telling you, okay, this is the roadmap to become a data scientist. Or no, that was never my focus. I know how to work with data scientists. I know how let's say the basics of data science, but I think nowadays there are so many specialities in data science, and I'm a bit outdated there. So, yeah, either get in touch with someone. Look at what Andrew Jones is doing with. Let me bring it up. Data Science Infinity. No, that's not it. Here. So look at what Andrew is doing. He has a 2-minute overview. Actually, it's so long since I was on this page. He's also creating projects here, right? So these kind of things I think are important for you to look at. All right. Okay. I hope you learned something. I hope this was helpful for you. We're going to share this. I think tomorrow we're going to also put in LinkedIn in this roadmap image so that you can use this. Sorry. And also you're going to be able to find this on our website. Again, if you want to follow this along, if you want to learn data engineering, again, the best platform is Learn Data Engineering. Right? Check out the introduction here that I've done. Look into this is where our students right now work. I've only looked at a few. 2 things. We have the Academy where you can go through everything that I have shown on your own. You don't need to wait for something or get help. Just start there. This is absolutely self-paced, and we have a Discord server where you can get help anytime with just posting in the server. This is fairly cheap, but if you want to have the best option, then just you can go to the coaching. You can just today I uploaded a video here explaining the coaching a bit better and talking about it a bit, and then you can discover if this works for you and schedule a meeting with me, a strategy meeting, and we have also explanations here how this works. And again, this is a bit more expensive. This is $1,500, but the Academy itself, you can start very cheap. You can start this for $264, either for 12 months, or unlimited access costs $480. So it's cheap. It's not expensive. All right. So, yeah, learndataengineering.com. I hope this was helpful. Next week, we're going to do another live stream, talk about stuff. And on the 11th of February, I actually have a a cool guest here. We're from Definity AI, where we're talking about Spark data observability, Spark optimization. A really cool topic. But I'm going to tell you more about this later point. Okay, so have a good one. See you next week. And if you, by the way, if you want to learn what is up with Learn Data Engineering this year, check out my YouTube channel. I posted a video yesterday about what's about 2024 for us and what's coming this year. And there's a lot of cool stuff coming this year to learndataengineering.com, to the academy and the coaching. So again, see you next time.